One application of derivatives is relating an object's position, velocity, and acceleration at any given time. So if s of t is a position function, so we're going to use s to represent the position of some particle or whatever it happens to be, some object. If s is the position function, then s prime is v of t, which is the velocity function, and s double prime, or v prime, is the acceleration function. Okay, so basically you have position function, the first derivative is velocity, the second derivative, which is the derivative of the velocity, is the acceleration. Okay, so the equation of motion of a particle is s equals 2t cubed minus 5t squared plus 3t plus 4, where s is measured in centimeters and t is in seconds. Find the velocity and acceleration of the particle as functions of time. What is the acceleration after 2 seconds? So, to find the velocity function, v of t, I just need to do the derivative of the position function. So the position function is what we just read. The velocity, if I do the derivative of that, I'm going to get 6t squared minus 10t plus 3. There's our velocity function. The acceleration function is simply just the derivative of that. So that would be 12t minus 10. What is the acceleration after 2 seconds? That just means I want to find what a of 2 is. A of 2 is going to be 12 times 2 minus 10, which would be 24 minus 10, which is 14. And our units here are centimeters per square second. So I want to talk about one more thing here, and then I'll be done with this video. If you talk about the position of something, usually your unit is something measured is a measure in distance, right? So something like centimeters or something like feet, it's a distance unit. Okay, so I'm just going to say like feet, for example. Okay, when you do the derivative and your independent variable is time, then what you're doing is you're doing what's called a derivative with respect to time. So you're saying, how does this thing change over time? Which means that's why velocity is feet per second, because it's if my units are in feet and seconds, it's how is the distance changing with respect to time as time changes, feet per second. And then acceleration, we're again going to do the derivative with respect to time. So that's why that would become feet per second squared. Okay, and every time you do the derivative, you're doing with respect to time again, and that is always going to increase the s's on the bottom. Okay, there is actually a derivative of acceleration, how the acceleration changes, and that is what's called jerk. So feet per second cubed would be the jerk of a particle or an object over time. But we are primarily going to work with the position, the velocity, and the acceleration.